Hi guys, I'm Michael J. Vargas and today I would like to present to you my first topic or process approach of QMS principle number 4, which is the sampling plans. So let me introduce to you first the sampling plans. Sampling plans are hypothesis tests regarding product that has been submitted for an appraisal and subsequent acceptance or rejection. The product may be grouped into lots or may be the single pieces from a continuous operation. The illustration below shows the basic idea. Starting from inputs, then it will undergo different processes to make a product. Getting a sample from products to do inspection that shows the data to decide whether to control, rework, accept, or reject. There are three objectives of why we inspect the product. First, we report the quality level of the manufacturing department to management. Second, provide adequate safeguards against the shipment of defective products. Third, assure that the manufacturing department has performed its quality functions properly. Next is the methods for checking the product. First, no checking. No checking may be warranted when the process capability is known and the probability of defective products is very small. A periodic audit to verify that the conditions have not changed is a recommended practice when products are not checked on a routine basis. In some cases, incoming materials from various suppliers may not be inspected because the supplier has demonstrated outstanding quality capabilities. At the other extreme, product may be inspected 100%. In certain circumstances, 100 or even 200% checking may be necessary, particularly where lives are involved. 100% checking is a sorting operation to separate good product from defective product. In addition, 100% product checking cannot be used when a destructive test is made, as the number of quality characteristics being checked increases, the effective of the inspector decreases. Next is the unscientific sampling technique known as the constant percentage sample, which is a very popular procedure. This sounds like a logical procedure to many people. Why not make it easy and take a 10% sample from the lot? The problem with this method is that the sample taken from small lots may be too small and the sample taken from large lots may be too large. The inspection accuracy is not achieved for small lots and too much time and effort may be spent on large lots. Next is the random spot checking. It may sometimes be used when a process is in statistical control. The random check is used to verify that the process is in control and to report the product quality level. The sampling risks are not known, so this method will not guarantee that the outgoing quality will be at an acceptable level. This type of sampling may be used when a supplier has been certified as providing excellent quality products over some length of time, or the process capability is so good that the other methods of inspection are not necessary. Next is the audit sampling. It is sampling that is done on a routine basis, but acceptance criterion is not specified. Audit sampling is used where the manufacturing quality controls are known to be working correctly. The process capability must be known, and the chance of defective products arriving at the inspection point must be very small. Next is the acceptance sampling, which is a major component of quality control and is useful when the cost of testing is high compared to the cost of passing a defective item, or when testing is destructive. It is a compromise between doing 100% inspection and no inspection at all. Now I will discuss to you the four categories of acceptance sampling. First is the lot by lot single sampling. The single sampling plan is a decision rule to accept or reject a lot based on the results of one random sample from the lot. The procedure is to take a random sample of size and inspect each item. If the number of defects does not exceed the specified acceptance number, the consumer accepts the entire lot. Any defects found in the sample are either repaired or returned to the producer. If the number of defects in the sample is greater than the acceptance number, the consumer subjects the entire lot to 100% inspection, or rejects the entire lot and returns it to the producer. Second is the lot by lot double sampling. It is used if there is not a clear accept or reject decision from inspection of the first sample. A second sample is taken and the decision is made based on the results of the combined samples. Third is the continuous sampling, which is used where product flow is continuous and not feasible to be formed into lots. When inspection begins, the product is checked 100% until parts are found to be defect-free. At this time, 1 out of X shall be inspected. If F equals 1 over 10, then 1 out of 10 parts will be checked. The sampling will continue until a defect is found. When a defect is found, 100% inspection shall resume and the cycle starts over. When rejected parts are found to be defect-free, the sample 1 over X shall start again. In most cases, the inspector will not perform the 100% inspection. The inspector will mark the last sampled part and the manufacturing department will perform the 100% inspection or detailing operation. The fourth one is the sequential sampling. The inspector will select one part from the lot and check for the specified requirements. The part will be classified as good or defective. A chart like the one shown below is specified for various sequential sampling plans. The required quality levels determine the acceptance, rejection, and continuous sampling regions on the chart. The chart shows the inspector what decision to make after each sample is inspected. The lot will either be accepted, rejected, or another sample will be taken. This procedure is done on a lot-by-lot basis. The advantage of this type of sampling plan is that a decision could be made based on a relatively small sample. Next is the operating characteristic curve or the OC curve. The operating characteristic curve is a picture of a sampling plan. Each sampling plan has a unique OC curve. The sample size and acceptance number define the OC curve and determine its shape. The acceptance number is the maximum allowable defects or defective parts in a sample for the lot to be accepted. The OC curve shows the probability of acceptance for various values of incoming quality. An OC curve is developed by determining the probability of acceptance for several values of incoming quality. Incoming quality is denoted by P. The probability of acceptance is the probability that the number of defects or defective units in the sample is equal to or less than the acceptance number of the sampling plan. On the right side shows the graph of OC curve. There are three probability distributions that may be used to find the probability of acceptance. First is the hypergeometric distributions. The hypergeometric distribution is used to calculate the probability of acceptance of a sampling plan when the lot is relatively small. It can be defined as a true basic probability distribution of attribute data, but the calculations could become quite cumbersome for large lot sizes. On the right side shows the formula for the hypergeometric distributions. Next is the binomial distributions. The binomial distribution is used when the lot is very large. For the large lots, the non-replacement of the sampled product does not affect the probabilities. The hypergeometric takes into consideration that each sample taken affects the probability associated with the next sample. This is called sampling without replacement. The binomial assumes that the probability associated with all samples are equal. On the right side shows the formula for the binomial distributions. Third is the Poisson distribution. The Poisson distribution is used for sampling plans involving the number of defects or defects per unit rather than the number of defective parts. It is also used to approximate the binomial probabilities involving the number of defective parts when the sample is large and P is very small. When sample is large and P is small, the Poisson distribution formula may be used to approximate the binomial. On the right side shows the formula for the Poisson distribution. You can check these sites for your reference. And I'm going to close my presentation with a quote from William Foster. Quality is never an accident. It is always the result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives. Thank you guys for watching. I hope you learned something from me. Thank you.